Assalamu alaikum and welcome to Abdullah Sir Science class. In today's class, we'll be looking at the problems of acceleration. If you haven't learned about the acceleration yet, then do watch my previous video. Okay then, let's get started. Welcome back. In the last class, we have learned about the acceleration. Acceleration is equals to rate of change of velocity. Remember, rate of change of velocity. Here I wrote. So, rate of change of velocity, in a sense, change in velocity with respect to time. The word rate always refers to time. Remember. So, if the velocity change I have to find out, consider the car is moving with velocity some u. This u here is initial velocity, right? And the car moves now moving with some different velocity. This velocity is called final velocity. So either you name it as initial and final, or you can just mention it or represent it as v1 and v2 as well. But always remember, to find the acceleration between the car, to find the acceleration, the velocity change, then we must subtract the final velocity minus initial, right? So v2 minus v1 or v minus u by t is the formula. What is the formula? V minus u by t. Here v is final velocity, u is initial velocity, and t is time. Okay, let's have a look at the one of the problem. So before going to that, we'll be writing the SI unit of acceleration. Let's have a look. Acceleration A is equals to rate of change of velocity. Okay, here change in essence final velocity minus initial velocity to get the change and the time. Okay, this is the formula. So velocity is SI unit. We are actually trying to derive the SI unit of acceleration. Velocity's SI unit is meter per second. Okay, remember, and the times SI unit is again a second. So if it is meter per second by second again, then if you do the reciprocal, meter per second into 1 by s will become meter per second square. Okay, all right. So the SI unit of acceleration is meter per second square. Okay, I hope you're understanding it well. Well, this is the SI unit of acceleration. Acceleration's SI unit is meter per second square. So we keep power 2 on the second time. So that, let's have a look at the problem now. So if you see, there is an example here of 8.4. I request you to please solve by yourself because the answer is already given here. There are some extra questions given, and the second question I'm going to solve for you. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Alright, let's have a look. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. So let's write the given data for this example. Before writing it, let's try to understand the problem. The problem is clearly saying you that there is a bus which was running with a speed of 80 km per hour. So this is the initial velocity. What is the initial velocity? 80 km per hour. Alright, and this bus, what happens? This bus decreases its speed. So it applies the brake maybe and has decreased to the speed of 60 km per hour. So this velocity is now final velocity is 60 km per hour. Alright, okay, that all happens in just 5 seconds. So time needed for the bus to apply brake from and reach from 80 km per hour to 60 km per hour is 5 seconds. Alright, now 5 seconds is the time we got. Now let's have a look. He is asking us to find acceleration. Alright, acceleration can be found by the formula. Let's write here. A is equals to final velocity minus initial velocity by time. But always remember, before solving the problem, you must write the given data and you must write the formula and think what SI unit the answer you want in. We want the answer of the acceleration to be in meter per second square. Alright, but please see here the values given are in kilometer per hour. So to solve the problem, we have to convert this kilometer per hour into meter per seconds, right? So the value of speed, that is velocity, initial velocity, is equals to u 80 kilometer per hour must be converted. So before going for the conversion, we must learn how to convert the kilometer per hour units into meter per second. A very simplest form. Let's try to learn. 1 kilometer, alright, has 1000 meters in it. Alright, 1000 meters makes up 1 kilometer, and 1 hour is of 60 minutes. Okay, if you multiply with 60 again, you will get in seconds, because each minute has 60 seconds again. So total in 1 hour you have 3600 seconds. Okay, so you have 3600 seconds in 1 hour. We got 1 kilometer has 1000 meters. Alright, let's try to convert 1 kilometer per hour. So to convert a kilometer per hour, let's write, instead of kilometer I will write 1000 meters here. Okay, 1000 meters, and 1 hour has 3600 seconds. Okay, I got that right. So 0 0 0 0 cancel. What is remaining? 10. What is remaining? 10 by 36. 10 by 36 meter per second, right? That means 1 kilometer per hour is 10 by 36 meter per second. Alright, one more easiest way is not to stop here. Divide the value, right? Let's divide it. How? 2 5s are 10, okay, and 2 18s are 36. What you got? 5 by 18. So to convert a kilometer per hour value into meter per second, you must multiply the number by 5 by 18. You must multiply the speed by 5 by 18. That's enough. No need to do this whole calculation again, right? Let's do it. Initial velocity u is equals to 80 kilometer per second, but we don't want kilometer per hour, right? We want meter per second. So what do? We'll multiply this value 80 into 5 by 18. If you multiply, so you can convert this value into meter per second, right? 8 5s are how much? 40. Okay, so it will be, since it is 0 is there here, 400 by what is remaining here? 18. Otherwise you can keep the values like this only for simple calculation. Okay, so we got u initial velocity as 400 by 18 meter per second, right? Let's not cancel it, let's keep it like that. Now we want final velocities also. Final velocity v is equals to 60 kilometer. Remember, it's given up. So if this 60 kilometer per hour should be converted into meter per second, then I must multiply by 5 by 18 again, right? Let's see. So I am multiplying again this number with 5 by 18, and 5 by 18 is equals to, I can either multiply these two number or I can use this number directly also. Alright, let's multiply them. 5 6 are 30 and 0 is again carried here, so 5 60s are 300, and what is remaining down? 18 meter per second. Alright, so you got initial velocity and we got final velocity also, and what we wanted actually, acceleration. Acceleration is equals to final minus initial by time. Let's keep it here. Acceleration A is equals to final velocity. How much is the final velocity? 300 by 18. So I will write 300 by 18 minus, what is initial velocity? 400 by 18. Okay, and what is down there? Time is still there. Time is how much? 5 seconds. Okay, now acceleration is equals to, you subtract, since the LCM, since the denominator having the same value, the LCM will be 18 again. Alright, let's use it. 300 minus 400 become minus 100, right? Because here the value of 400, the sign, the negative sign's value is more, so we get minus here. 300 minus 400 is minus 100 by 18. And what is down again? 5 seconds. Okay, so now again we are going to do reciprocal. Minus 100 by 18 into what? Since 5 is, this is the major by, and we can keep nothing. If nothing is there, what is there? 1. Then if it goes up as a reciprocal, it will be 1 by 5. So I should multiply this by 1 by 5. And now this cancel it. 5 ones are 5 and 5 20s are 100. So acceleration is equals to minus 20 by 18 meter per second. Alright, meter per second square. Remember, right? Acceleration's SI unit is A is equals to minus 20 by 18 meter per second square. So that's it for today's class. You can also try the problems mentioned in the textbook. Please try it, because unless you try, you will not become perfect. This is your Abdullah sir signing off. Stay tuned. Assalamu alaikum wa rahmatullahi wa barakatuh.